It's time to take a look at Lab 3.4, and before we start, I just want to make a mention of something. When I put these labs on video, it's not to replace what we do in classroom, but to add to it. If you've missed, or if you didn't, or you didn't grab some information, or you can't get it from someone, you could watch the video. The numbers are always going to be different than what we do in class, simply because there's always some variables that may change from classroom to classroom. So it's your responsibility to get the information from the classroom. This is just here to back up the idea so you can understand the concept. So for those of you who have been waiting to watch the video to do your labs rather than doing them in the class, well, there are going to be times where videos are not going to show up, okay? These aren't prerequisites, they're here to help you, all right? So now, if you remember 3.4, what we did is we took the plate and we filled it up to the rim with water, and the idea was to see which one of these beakers would last the longest. Well, beakers and flasks would last the longest with the candle inside of it. How long would the actual flame stay lit? And also to see some of the things that would happen afterwards. So what we did is we started off with this smaller 250 milliliter beaker. Okay, now first let me start up the candle. Okay, and this is the one that you guys did yourselves with the 250 milliliter beaker. And again, I got the stopwatch in my hand. Most of them went out in about 6 to 10 seconds. Okay, we're at 6 now, 7, 8, 9. Okay, so just about 10 seconds, and you can see the water here gets pushed up into the beaker. All right, so as I mentioned in class, it's 14.5 pounds per square inch on the outside. As the candle warms up the air inside, it increases its pressure, pushes some out, and then after the candle goes out, we end up having a small low pressure system in there to allow it to come on up. Okay, so moving from this one, if we let it equalize, the next step was to test how long it was going to last in the 1 liter beaker. Now, if the 250 milliliter beaker lasted approximately 10 seconds, and this being 4 times the size, how long do you think the candle should last there? Okay, well, let's find out. First of all, let's reset the stopwatch, put it on top, and press. Now, you can see there's been more displacement of the water around the edge. One, because it's bigger, but also it's got more air trapped within its volume, okay? And the candle is staying lit a lot longer. We're already at 13 seconds. But you can see it's kind of faltering already. It's burning away the oxygen. It's pretty obvious. And already the water has been pushed back towards the interior of the beaker. And as it goes out at 26 seconds, all the water that was on the outside and above the rim has now been pushed back underneath the beaker. And in fact, the only place where it's beginning to falter is right where the lip of the beaker is, right here. You can't see it from your angle, but where it is right here. Okay, so the final one to look at was the flask. Now, the flask is exactly the same size in terms of volume as the second larger beaker, okay? Exactly the same. The only problem is it's got a different shape, and of course the apertures are different. Look at the size of the lips around the beaker and the one that is here for the flask. There will be a difference here, one, because there's also sort of a pouring spout there on the beaker, which there isn't on the flask, but also because this takes up less area. Let's see exactly what happens. Okay, so we got the stopwatch, we start it, we put it down, and then we wait. Now immediately you can see it bubbling back here, or at least I hope you can, as the air is being pushed out. Now the air is being warmed up, expanding pressure, and as the oxygen in it slowly ebbs away and puts the candle out now, which is at 19 seconds, give it a couple of moments and you begin to see the water's already beginning to rise. In fact, the water's already risen up a quarter of the way up the candle. And in very short time, we'll end up being up as far as here. Now, I'm not going to go through that whole thing because it took quite a long time. But again, what you've basically done is you've burned away the oxygen that was there, or at least most of the oxygen. Maybe because of the shape of the beaker, we didn't quite get all the oxygen, but we got a lot of it, only because it's a little taller compared to the shape of this. Okay? So it's burned away oxygen. It's created a high pressure system within the bottle, and then with the candle going out, it returns to normal pressure. In fact, goes to below what normal pressure is, and the pressure of the air above and around the bottle is pushing the water back in and underneath the bottle itself. And already, the water's up to here. Okay? So, that's a demonstration of Lab 3.4.